Welcome to homework.
For our question, we have three lenses with focal lengths f1, f2, and f3. The distance from the object to the first lens is p1, and the distances between lens 1 and 2 is d sub 1, 2, and the distance between lenses 2 and 3 is d sub 2, 3. For part A, we're asked to find the distance to the image produced by the third lens. So first we have to find the distance to the image produced by the first lens. That's the object of the second lens. Then we have to find the distance produced by the distance of the image produced by the second lens, because that's the object of the third lens. Then we can find the distance produced by the third lens, or the image produced by that third lens. So first we're going to find I sub 1. To do this, we're going to use the small lens equation, which says 1 over I sub 1 plus 1 over P sub 1 is equal to 1 over the focal length f sub 1. I sub 1 is the distance to the image of the first lens, so we're going to solve for that. We find that I sub 1 is equal to 1 over f sub 1 minus 1 over p sub 1, all raised to the negative 1. We have to raise it to the negative 1 to get I sub 1 out of the denominator. We find that this is equal to 9 centimeters. So the distance from the object of the second lens to the second lens, which we call p sub 2, is the distance between lens 1 and 2, d sub 1, 2, minus I sub 1. Plugging in that value, we find that this is equal to 6 centimeters. Now we can calculate I sub 2 the same way we calculated I sub 1, but we simply replace f sub 1 with f sub 2 and p sub 1 with p sub 2. Plugging in those values, we find that I sub 2 is equal to 6 centimeters. Okay. Continuing, we now can calculate p sub 3, the distance from the object of the third lens to the third lens, and this is d sub 2, 3, the distance between lens 2 and 3, minus I sub 2. And this comes out to equal 5 centimeters. Now we calculate I sub 3 the exact same way as I sub 1 and 2, just again replacing. So this is going to be equal to 1 over f sub 3 minus 1 over p sub 3. We raise all this to the negative 1. We find that I sub 3 is equal to 7.5 centimeters. So we can box in 7.5 centimeters as our solution for A. Part B wants us to find the total magnification from the three lenses. We'll call that M. This is equal to the magnification of the first lens, negative I sub 1, divided by P sub 1, multiplied by the magnification of the second lens, negative I sub 2, divided by P sub 2, multiplied by the magnification of the third lens, negative I sub 3, divided by P sub 3. Plugging in all of these values, we find that the total magnification is equal to negative 0.75. We can box that in as our solution for B. Part C wants to know if the image that's created, I sub 3, is real or inverted. So to answer that, we just look at the value for I sub 3, and since the value for the image produced by the third lens is negative, the image is virtual. Or excuse me, it's not negative, it's positive. And since it's positive, the image is real. So since I sub 3 is positive, the image is real. And we can box it in as our solution for C. Part D wants to know if the image is inverted or non-inverted. So we look at the value of the magnification M, and since M is negative, the image is inverted. And lastly, part E wants to know if the image is on the same side or the opposite side of the lenses as object 1. And since the image is real, it is on the opposite side. We can box that in as our solution for part E in the final part of the question.